Hello everyone, thank you for joining me for our third written exam on Module 3, Chapters 4, Number Theory, and Chapters 5, Integers. I am Miss Akeisha, and this one's a doozy, so let's get started. This one looks hard, but it's really just a lot of work. So I'm only going to really do one column. I have the answers at the end of our thing. There we go. And I'll just pick a couple, but the point of this question is to use the divisibility test to decide if a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 2 for 684 is already done. So if you remember, the divisibility rule about 2 is that if the number ends in an even digit, it's going to be divisible by 2. So 4 is even, 4 is even, 1 is not, but 0, 0, and 8 are. So on to 3. The divisibility rules for 3 are if you add up all the numbers in a number. So you add 684, and if that number is divisible by 3, then the whole number is divisible by 3. So if you do 6 plus 8 plus 4, and so 6 plus 8 is 14, plus 4 is 18, and if you don't know that 18 is divisible by 3, then you can go one more step, and 1 plus 8 is 9. 9 is divisible by 3. So 684 is divisible by 3. Now for 4, you need to know that the last 4 digits of a number have to be divisible by 4 for the whole number to be divisible by 4. So if at 684, the last 2 digits are 84. If you divide 84, this one's kind of easy number. So 2 will go into 8, that will give you 2. And then 4 divided by 4 is 1. Pardon me, I am so sorry. So 21, so 84 is divisible by 4, meaning 684 is divisible by 4. 5, the divisibility rule is it has to end in a 0 or 5. So 684, it ends in a 4. So it's not going to be divisible by 5, but if you look down our row, you'll come across the 644,490 ends in 0, so that would be divisible by 5, as well as 2,676,740 ends in 0, but the last number isn't. So 6, the easy one about this is if it's divisible by 2 and it's divisible by 3, then it is absolutely divisible by 6. 7 is a trickier one, and on the next slide, I do have how to solve this. But to find how to do that, you take let's go to that slide. Here we go. So you take the number, and then you're just going to subtract it by the end digit. So you can see 68 minus 8 is 60. Is 60 divided by 7? It is not. And you can go all the way down until it's an easy number. So, but it can also equal 0. So if you can see way down here, you got the 644,490. You subtract the 0, you get 64,449. Then you have to double it. Sorry. I didn't do that right. But it still isn't equal, divisible by 7. But so like the last digit's 9, you multiply that by 2, and it's going to be 18. So 6,444 minus 18, 6,426. 6 times 2 is 12. 642 minus 12 is 630. 0 times 2 is still 0. So 63 minus 0 is 63. And 63 is divisible by 7. You multiply by 9 into it. So let's go back. And let's look at 8. The divisibility rule for 8 is that the last 3 digits must form a number divisible by 8. And this one would be one to get a calculator on, but we can look at 2064. The last 3 digits are 064. 64 is divisible by 8. So 2064 is divisible by 8. Whereas 51,051 is not, because the last 3 digits are 51, and 51 is not divisible by 8. So the whole number is not. So at 9, the sum of the digits have to be divisible by 9. So for 684, we got 6 plus 8 is 14, plus 4 is 8, 18. 18 is divisible by 9, so 684 is divisible by 9. The divisibility rule for 10 is that they have to be divisible, or have the last digit end in a 0. No ifs, ands, or buts. Last digit must be 0. So the only 2 numbers that would even be divisible by 10 would be our 644,001 and our 2,000,001. And then the rule for 11 is really long. And I have that written on a slide a little bit further. So let's go take a look at it. Here's our 8, 1. Here's our 9s written out, and here's our 11. So what you have to do is think of it as each place is a power of 10. So 4, 10 to the 0 power. And then 10 to the first power, 10 to the second power. But then you're going to transfer it into 11. And so 11 will go into 109 times, giving you 91, and then plus 1 is 100. Whereas the 10 would be 11 minus 1. And then you're just going to treat this like a FOIL method. So you got 6 times 9 plus 8. And then the like term is going to be 11. So when you take that out, now you have 6 times 1, which would be 6, which is what you'd have over here. So you have the multiplication up here. with the addition sign. And then you have what's outside the parentheses. So you got 6 minus 8 because there's a minus sign right here. And then 4. So we already know this part is divisible by 11. So you're just going to add these up, subtract them, find the solution. So 6 minus 8 is -2, plus 4 is +2. That's not 0 or 11, so the whole number is not going to be divisible by 11. And on to the answers, which are right here. So moving on to the next one, which will be a little bit easier. And I'm just going to do the first one, which is 416 got 7,490, and then 69,844. And we're going to use the process of nines to find the answers. So they have it equaling to 112,790. So 4 plus 1 is 5, plus 6, which is 11. And then you're going to subtract the 9 from it, whatever multiple of 9 it is. So 9 times 1 is 9, giving you a remainder of 2. So 4 plus 7 is 11, plus 9 is 20. So the multiple of 9 would be 18, but that also leaves a remainder of 2. So 6 plus 9 is 15, 23, 27, 31, and so the multiple of 9 would be 27. 31 minus 27 is 4. And you're going to add these up and take the 9 out of that. So 2 plus 2 is 4, plus 4 is 8. So you can't take a 9 out of that, so it's just 8. So we have 1 plus 1 is 2, plus 2 is 4, plus 7 is 11. Plus 9 is 20. Which will then give you a remainder after taking out the multiple of 2. So if you bring out a handy dandy calculator, you see that they don't match, so you're going to want to recheck it. So 416 plus 7,490 plus 69,844, and that gives you 77,750. So let's check that just by using the cast out nines. So 7 plus 7 is 14, plus 7 is 21, plus 5 is 26, And if you cast out the 9s, you'd get 18. Or you can just add them together again. So 2 plus 6. That's also going to give you 8 as a remainder. Now they match. So now you know that the answer is right. And the trick part of this is that it's going to be, if you're adding in the problem, you're going to have to add your remainders. If you're subtracting, you're going to subtract. Multiplying, multiplying. And that is how you're going to cast out 9s for your answers. Let's go on to question 3. Woohoo! All right, this one's hard, but you're going to have to stick with me for my very artistic drawings. So we have little rods here that are 1 centimeter square, but they have different lengths. So 1, 2, 3, 4, all the way up to 10. So the first part is, which of these rods are going to measure the 9 rod? And you're going to imagine, say this is 9 centimeters long. Which of these will add up but not be too small or too big to be 9? And it's going to be it in general, the same. So you're not going to do 4 and 5 equals 9. You're going to do 9 1s or 3 3s. So imagine these were at least 3 centimeters. You got 9 1 centimeter ones, and then 3 3 centimeter ones. And the same is going to go for a little 6. I got rid of the rest of my box. There we go. So you're going to have 6 ones, or you can imagine 3 2 centimeters, but you can also imagine 2 3 centimeters as well as one 9 centimeter and 1 6 centimeter, obviously. And then the trickier one is going to be if we place the 10 rod and the 8 rod end to end, they're going to form an 18 rod. So imagine super long 18. I know I am such a great artist, right? I'm a regular Picasso. So we're going to find the rods that, if placed end to end, are going to measure 18 without any gaps or overlaps or even falling short. So we know the 1 centimeter rods can go into it 18 times. Oof, that is a lot. But if you remember our divisibility rules, say that 3 times fast, you know that it ends in an 8, which is an even number. So we can also get the 2 centimeter rod in there. And using the divisibility rules, 1 plus 8 is 9, which is divisible by 3. So we can get our 3 centimeter rod to work. But I don't think the 4 or 5 will. But can we get the 6? Well, if 2 or 3 can, then yes, we can definitely get the 6. And then 7, no. 8, no. Because 4 isn't, so 8 really probably isn't going to be. But 9, 1 plus 8 is 9. 9 is divisible by 9. So yes. And Well, we're at 10 and there's no 18 rods. So if there was an 18 rod, it would work. But other than that, that's all of our rods that we'll fit there. That wasn't too bad. It was just hard when you have to draw it out. How can you be so accurate, right? So let's go on to question 4. And we're going to use the least common multiple method demonstrated in this table, right here, to factor out the prime divisors. Sorry, I'm tripping over my tongue today. And we're going to replace each term containing by the quotient. So the trick of this, and this one's really fun, is we're going to take these numbers, and I'm actually going to do B. And you're going to put them up here. So we got 40. We got 12. 44. And 363. And now you're just going to use prime numbers to find the least common multiple. So starting up here, I know that 2 can go into 40, so I'll put a 2 there. So 40 divided by 2 is 20. But we're going to keep going down the row. And 12 to be divisible by 2? Sure can, you get 6. 44 will give you 22. And 363 is not divisible by 2. But we're going to keep trucking. I know 20 is also divisible by 2, so we're going to keep at it. So that's going to give me 10, 3, and 11. Oh, but bring down your 363. That way you can keep working with it. But it's still not divisible by 2, so we're just going to bring it down again. I'm going to keep working at it. I know 10 is also divisible by 2, and that's going to give me 5. 3 is not, but bring it down. 11 is not, and we're going to bring it down. And 363 still isn't, so bring it down. All right, and looks like we have all prime numbers except we got this big old number over here. That can't be prime, can it? Well, we know there's a lot of 3s and 6s, so I'm going to take a guess that it's divisible by 3. Let's add it up. 3 plus 6 is 9, plus 12. 3 is 12, sorry. And 12 is divisible by 3, so let's go ahead and put our 3 over here. 3 isn't going to go into 5, so we'll just bring that 5 back down. 3 is divisible by 3, so that'll give us 1. And won't go into 11, we'll just bring that down again. But it will go into 363, so we got 121. And if you know your perfect squares, you're going to know that 11 squared is 121. And 11's prime, believe it or not. So we're going to put our 11 over here. It won't go into 5, so bring it down. Bring it down to 1. 11 divided by 11 is 1. And then 121 divided by 11 is 11. And looks like we got all prime numbers. So we're going to have the answer of 2 cubed times 3 to the first power times 5 to the first power times 11 squared. And this will be a little easier if you get your handy dandy calculator So we'll do 2 to the third power, which is 8, times 3 times 5, times 11 squared, which is 121. And that gives us a least common multiple of 14,520. That is a really big number. But it was so easy to find rather than multiplying 40 times whatever number to get 14,520, right? And you're just going to do the same with the other two problems. Let's move on. That wasn't too bad. It's one of my favorite things to do, especially when you just want to waste some time writing down numbers. It's like the lattice method, but for finding least common multiples. Number 5 is if in a machine there's a gear with 48 teeth, and it's engaged with a gear of 84 teeth. And we have points A and B, and they're lined up, see? Lined up. And we want to know how many revolutions the small gear is going to have to take before A and B are in position again. So, first thing I like to do is I want to see if they're divisible already. And it's kind of hard to see that with 2 double-digit numbers. So if you want, you can do the least common multiple method. Do 48 and 84. And I know 4 is going to be divisible by them. And so I'll just put a 2 squared so I know. And so it's going to be 4. Think of it as 4. It helps if you kind of put that out to the side. So 48 divided by 4 is 12. 84 divided by 4 is 21. I know 3 is going to be divisible into both numbers. So 12 divided by 3 is 4 again. And then 21 divided by 3 is 7. You can do another 2 squared to get rid of that 4. I'll give you 1 and 7. So your multiple is going to be 2 to the 4th power times 3 to the 1st power times 7 to the 1st power. And you could have also just brought out your handy dandy calculator to see if 84 was divisible by 48. But if you know 2 to the 4th power is going to be 16 times 3 times 7, which is 36. So that's going to be the least number that they both go into with A and B meeting at the same place. So now we're going to divide. Let me write that down so we don't forget. 336. So we only want to know for A, oh, that's a very bad A, which is 48 teeth. So 336 divided by 7. So the answer is going to be the small gear has to make 7 rotations before it will line back up with B. And if you want to know that, you're just going to divide 336 by 84. And that's going to be 4. So for every 4 rotations for B, it's going to be 7 rotations for A. Wasn't too bad, right? I believe we have one more. Ooh, look, it's a magic square. How fun. So what you want to do is add up the integers. I like to see what will cancel out first. So you got 0, which is 0 already, and then 1 and -1 will equal 0. So I'll bring out the handy dandy calculator once more. And we can see -7 plus, let's clear that. There we go. -7 plus -6 plus -4, -5, sorry, -3, -2. That'll give us -27. So now we're going to take -27 and divide it by 3, because you've got 3 rows. And that's going to give you -9. So each one has to equal -9. And I see that 0 is in a corner, so we already have that, and 1. Well, if you know your 9, and 8 isn't here, so we have the pairs that will go together to be -9 are going to be 7 and 2, 5 and 4, and 6 and 3. Well, that leaves -1. And if you think about the others have to be with 0, that only leaves one spot left. -1's going to have to go right there. And then this is where it gets a little tricky. So now you have to line up the pairs so that each row equals -9. So if we take 7 and 2, yep, and that will equal -3. Well, -3 will go with -6. And then if we put a -3 here, because there's our pair, it's going to have to be here, here, and here are 9. So these equal -9, this equals -9, this equals -9. Now let's look at this row. We got -7 plus -3 is -10 plus 1, -9. All right, and that only leaves 5 and 4. Let's see what we got here. -1 and -3 is -4. And we know -4 plus -5 is -9. That leaves one spot left for -4. Let's make sure it works. I got lucky with this being on my first try. So you got -4 plus 1 is -3. -3 plus 6 is -9. Woohoo! That was a lot shorter than I expected to be. I got lucky. Thank you for joining me for our 3rd written exam. I hope that it wasn't too hard. And I can't wait to see you guys on our next written exam. You have a great, great, great day.